Hi, this is Mrs. Vrobel. This is part 2 of periodic law and trends in the periodic table. Today we're going to talk about some of the characteristics of properties of elements when we look at the periodicity. So how often does it repeat itself? So we just finished talking about how the elements are arranged and some of the families that we have. Now we're going to go into some more details about the chemical or physical properties of the elements. So here we have a periodic table that describes metals, metalloids, and nonmetals. So if you were to draw an arrow, the metallic character actually decreases when you go left to right. And that makes sense because we have this little hot corner here of nonmetals. Notice that it actually increases as you go from top to bottom, and that makes sense because when you have electrons that are less tightly held to the nucleus, they're able to give themselves up and form cations. Remember, we talked about cations last video, and that's essentially what we're looking at here. Okay, there's a couple other properties that we need to look at. The first one is ionization energy. So how likely is an element going to form an ion? That means that we need to put energy into removing an electron, and how much energy is required for removing that electron. So if you had to guess, which of the two types of elements would be more likely to have a low ionization energy? Would it be metals or nonmetals? Metals. So metals should have a lower ionization energy. We'll see if that's true. Electron affinity. So how much more stable is an element when it accepts an electron? You may notice that some elements are more likely to be lower in energy. They'll give off some energy when they accept an electron. So if you had to guess, which of the two do you think would be higher in electron affinity? Would it be a metal or a nonmetal? Yes, hopefully nonmetals, you see this happening. Okay, so here is a table, and in this table we actually, it's important to look at the axes so you can determine what you're looking at. So now we're looking at atomic radii. So we're looking at how wide is the element. Now notice at the very top here, the alkali metals. So this is the very first family on the, oh, I'm looking at the wrong side, on the left-hand side of the periodic table to you. Okay, they have the greatest atomic radius. Notice that the noble gases have the smallest atomic radius. So as we go from left to right, something interesting is happening. How come the size is decreasing? Why isn't it increasing? Because we're adding electrons, we're adding protons. That doesn't make any sense. Okay, here's ionization energy. So with ionization energy, something else is happening here. Look at all the noble gases are at the top. Okay, so the energy that's required to remove an electron is higher. So ionization is higher for noble gases. Now notice at the bottom there, we have lithium, sodium, potassium, rubidium, cesium. So notice that the ionization is actually lower for the alkali metals. And that makes sense because these guys, they're willing to give up their electrons to be cations. The noble gases, they're satisfied. They want to hold on to their electrons. So their ionization energy is higher because they want to hold on to their energy. Notice the trend too as you go up with atomic numbers. So as you add an increasing number of protons and electrons, the ionization energy actually decreases over time. Okay, so now we want to talk about electron affinity. And remember, this is the amount of energy that is released when an element accepts an electron. So notice that the electron affinity increases. And that makes sense because as you go up a group towards the top, those electrons are more tightly held, so more energy is going to be released as it accepts an electron. The same goes as you go from left to right, okay? As you have electrons being given to the elements on the right-hand side of the table, notice that more energy is being released. They're more tightly held. Therefore, the infinity increases as you go from left to right. Okay, so these are the trends that are found within the periodic table. So notice that when we're looking at atomic radii, it essentially decreases across a period, but it increases down a family. The reason why this happens is as you increase the positive charge of the nucleus, the electrons see a greater positive charge. So the attraction to that increased positive charge is greater. Hence the contraction of the atomic radii. Whereas if you're going down a group, the layers of electrons are increasing. Even though the nucleus is getting bigger, they're not necessarily seen as strong of an attraction because we call it shielding. The inner electrons are actually shielding the attraction that the outer electrons have. For ionization, we have an increase across each row. So as you go from left to right, the ionization energy increases because the electrons are more tightly held when you get to the noble gases. However, notice that when we're talking about ionization energy, the electrons are less tightly held as you go down a family. So the ionization energy, the cost of removing an electron is smaller as you go down a group. Once again, the increase of electron affinity occurs across a row. So electrons are more tightly held when you go from left to right. Notice that the affinity is actually 0 with noble gases because they no longer need extra electrons. They're done. They're satisfied. However, if affinity does decrease as you go down each family, and that makes sense because the electrons are less tightly held, you don't see as much of a energy stability as you get lower or down a group. And then lastly, for metallic character, we decrease going from left to right, which makes sense. We're starting off as metals, and eventually we increase the non-metal character, so metallic character decreases. And notice that if you want to increase metallic character, you're going from top to bottom. So as you get down a family, you see more easily a formation of a cation, which is more metallic in character, and you see an increase. Okay, here we go. This is a summary for metals. Notice that metals tend to have few outer electrons, so wherever you see the term valence, we're essentially talking about outer electrons. I think there's an extra T in there. Notice that for metals, we're talking about large atomic radii, so they see a smaller positive charge, so it's almost as though they're bigger in size because of that. Notice that they have low ionization energies because they're more willing to give up their electrons. For nonmetals, I'm sorry, I have one more bullet for metals. Metals have the ability to lose electrons and form cations. For nonmetals, notice that they have a greater amount of outer electrons. They also have a small atomic radius. Remember, they have a greater positive charge, and that greater positive charge attracts the electrons more tightly. They have high electron affinities. They are stable when they accept their electrons because they want more electrons. And they typically form anions or negative ions.